Hi everyone, this is me Hassan and welcome to my channel Hassan Academy. Today we are going to discuss one more question which can be very much important for Iit-Jee or Neet kind of exam. So if you are an aspirant, you have to pause this video and try to find out both the answer. Okay, then I will explain you definitely. And if you require any help or anything, you can write in this email. I already got one email. I will make a short video about it. Okay, now come to here. First of all, they have given this compound N-methanol and they have given heat. This heat is very important. Okay, if heat is not given, then it is very difficult to understand sometimes that what type of reaction is going to happen. Okay, anyway, there is two things by seeing which you can understand that whether it is a elimination reaction or substitution reaction. Here it is elimination reaction. So if you see this heat, you should understand that there is a very good possibility that reaction can be going for elimination. Okay, and another way is by seeing the option. By seeing the option given here, you can see that all the option they have given double bond, so that means it is elimination reaction. Okay, sometimes they are not giving option in this way so that you get confused. They will give two option for elimination, two option for substitution. At that time you have to understand by seeing this only. Okay, anyway, come here. This is the elimination reaction, and which type of elimination? E1. So what I need to do, so whenever you get that this type of elimination reaction, and basically for E1 or SN1, first you remove that halogen given. Okay, don't do anything, just remove that halogen, positive charge, and methyl is there. Now you know already that in case of substitution SN1, nucleophilic substitution 1 and elimination 1, you can do the rearrangement of that carbocation produced. Okay, so now if possible you have to do the rearrangement of carbocation so that you get more stable carbocation. Now see here what is there. From this side only inductive plus I is there and 2 proton is there, from where you can get the hyperconjugation. Okay, so 2 alpha hydrogen is there, but if I do 1,2 methyl shift, 1,2 methyl shift, okay, from this 2 methyl 1 methyl I am going to transfer from here to here, and so that this positive charge will come to here. Okay, now you see, now this carbocation is more stable than the other one. Okay, previous one, this is secondary, now it is tertiary, and number of alpha hydrogen also more. From here 3, from here 2, 5, from here 1, 6 alpha hydrogen is there. Okay, so once you got your most stable carbocation, after that you have to see that in this situation from where I have to take one proton, I have to remove one proton so that I can get the most stable alkene. Okay, final product is alkene, most stable alkene. So if I remove from here one hydrogen like this proton, this electron will come here and I can get here double bond methyl. This compound I will get, and this is the most stable alkene I could produce from this carbocation. So where it is? B. Here is the option. Okay. So this type of tricks you have to know that whether it is E1 or SN1. Once you know that it is E1 or SN1, first of all produce carbocation wherever halogen is there. After that you try to do the rearrangement or whatever possible, ring expansion, ring contraction, to make it carbocation more stable. And once you got the most stable carbocation possible, after that only you have to produce the alkene. Which type of alkene? Most stable alkene one. Okay, and you can see out of this 4 product, everywhere alkene is there, and this is the most stable alkene. Okay, 3 plus 3 6, 6 plus 2 8, 8 plus 2 10, 10 alpha hydrogen is there. Okay, anyway, let's go for option question number 2, second question. This is very important question, and I want to tell one thing that regarding this concept, so many times question came in JEE, even in Neet, because this is a very important rule you should know from before, that is called Bragg's rule. Okay, what is this compound? Remove this chlorine. What is this compound? It is a bicyclic compound. Yes, bicyclo 2,2,1 heptane. This is also called norborane. Okay, norborane. Not burning. Norborane means one double bond will be there. Norborane. Okay. Once you know that these are cyclic compound, bicyclic compound, and here two things you should know. Bridgehead carbon. Here this one and this one is bridgehead carbon. Okay. Now what is Bragg's rule all about? I have seen students getting very confused about Bragg's rule, and they know few direct statement which are not true always. Okay, sometimes it's correct. They are telling that sir, as per Bragg's rule, whatever that bridgehead carbon is there, that should not have any positive charge or negative charge or double bond, but original Brad's rule is not like that. It is saying that bridge head carbon should not be sp2, or bridge head carbon should not come under planarity, but here also some condition is there. Once you get a ring size 8 or more than 8, from 8 onwards or more than 8, once it is increasing the ring number of ring carbon, then you can go for planarity. Okay, but mainly this bridge head carbon should not be sp2 carbon. Okay, for that you have to understand that it should not be positive charge, ch positive charge, or it should not produce any double bond. Okay, mainly that thing. Now they have given three compound, right? And based on these three compound, where SN1 will be order will be more faster. Okay, I have not given option, you have to tell your own option. A, B, C, three option is there. What is SN1? SN1 means you have to remove that, and you have to create the positive charge. That's all about SN1. Yes, and here also you can remove and positive charge, and here also you can remove and positive charge. Now you see where positive charge is most stable, that their rate will be more faster. This positive charge is not possible at all, because it is sp2 hybridized and carbocation is sp2 hybridized, and bridge at sp2 is not possible, so this reaction is not going to take place. So A will be the last one. Now between this one and this one, you have to decide which one is more stable. If you see, this is 3 degree, this is 1 degree. Yes. Now in this 3 degree, let's ask you one question. This is a carbocation, hyperconjugation is possible. Now you should tell me here how many alpha hydrogen will participate in hyperconjugation. How many alpha hydrogen is there? First of all, 3 plus 2 plus 1, 6. 6 alpha hydrogen is there, right? But out of this 6, only 5 will participate in hyperconjugation. This one is not going to participate in hyperconjugation, because if this one will participate hyperconjugation, you will get double bond here, which is not possible. Once it is going to be double bond, this carbon again it will be sp2. So out of this 6 alpha hydrogen, only 5 will participate in hyperconjugation. Anyway, this is more stable than this one, because this is 3 degree, this is 1 degree only. So B will be number 1 and C will be second. So B, C, A. This is the order you should get. Hope everyone got this answer, and thank you for watching. Do share with your friends so that I can make more and more video.